Welcome back, College Math. Hope you had a restful fall break. I hope you were able to recharge your batteries a little bit. I hate to throw you back in to math, but we got to keep going, okay? We got 9 more weeks, and then you'll be done with math, at least in high school. Let's go ahead and start off on a good note. Let's finish strongly so you can pass this class, hopefully with a B or an A, but a C is good too. No worries. And then get your DE credit too. Get that college credit for this class. It's good. Okay. So ask all those questions, get the help that you need, and let's keep going. All right. Pick back up in section D.2. We're going to finish this quick little algebra review. We're going to talk about exponential and logarithmic equations. Our objectives are to solve these equations, so solve logarithmic equations by rewriting them as exponentials, okay? So we're going to use exponentials to help us solve these logarithmic equations. And then backwards, either we're going to go ahead and solve exponential equations first by using a kind of nicer method called relating the bases, but we're going to find that we can't always do that, so sometimes we're going to end up using logarithms and then calculating them, okay, using our calculators. Calculate logarithms in the calculator. Okay, so let's go ahead and get into it. Let's just start with some examples, okay? We have a few logarithmic equations here that we want to solve. All right, so let's go ahead and solve them, all right? Let's start by rewriting them as exponential equations. That's how we're going to solve them. That's going to be our main way to get our answer, okay? Because we want to get the x. So how do we rewrite them? If you remember, the base is the same. So the base of the logarithm is the base of the exponential. So 6, I switched the input and the output. So 6 to the third power, and actually in this case, the negative third power is equal to x. Okay, so if I want to rewrite this as an exponential, I get x is equal to 6 to the negative third power. Ooh, and you pretty much already have your answer. But let's actually figure out what 6 to the negative third power is. Well, x is equal to the negative third power, I can rewrite this as 1 over 6 to the positive 3. And then 6 to the third power, you might know it off the top of your head, but if you don't, jam it into your calculator. 6 to the third power is 216. So this is 1 over 216. Sweet. Okay, so log base 6 of this number is negative 3. So that would be our x. Cool. Let's keep going. Next one. 2 times log base 7 of x is equal to 8. Now, before we solve the logarithm, we need to kind of make sure of one thing. I'm only able to do this rewriting portion if the logarithm is by itself. So that's going to be a good note to write down. So maybe an asterisk or a note to yourself. Get log by itself. Okay. Get the log piece by itself. So we want to get this by itself. So let's get rid of this 2. The 2 in front, this is a number, so this is 2 times this number, which means we'll go ahead and just divide by 2 on both sides. So I get log base 7 of x is equal to 8 divided by 2, which is 4. Okay, so now I can rewrite 7 to the 4th power is equal to x. So x is equal to 7 to the 4th. Now, if you don't know off the top of your head, I don't blame you, neither do I. 7 to the 4th power is a big number. That is 2,401. That's the big one. Okay, cool. So that's the solution to this one. Let us keep going. Okay, so part C, let's solve for x. We want to get the log piece by itself first. So get this part by itself. This is 4 plus, so we want to go ahead and minus 4 on both sides. So I get log base 3 of x is equal to 2. And now I just do 3 to the second power is equal to x. So x is equal to 3 to the second power. We know what 3 to the second power is. That's 9. X is equal to 9. Okay. Cool. One last one. Log equations. We won't see them that often in what we're going to do for the next few sections in college math. But I think it's good to know, and it's good to kind of practice it as we get into the exponential equations, okay? So here's another one. We don't see a base, so what base is it? Base 10. Log base 10 of x plus 4 is equal to 2. Now the log part is already alone. It's already by itself. This x plus 4 is inside the logarithm. I do not want to subtract 4 here. That's bad. Don't let me see you do that, or else I'm gonna, I don't know, I'm gonna be sad. I'm gonna cry. Don't make me cry, okay? So don't do that. Log part's already by itself, so let's proceed. Let's do 10 to the second power is equal to the entire expression we have in here, x plus 4. So x plus 4 is equal to 10 squared. What's 10 squared? That's 100. X plus 4 is equal to 100. Subtract 4 on each side. Ooh, what do we get? 96. Coolio. Okay, not too bad. We'll go ahead and practice that more in your practice set. Let's move on to some better stuff. Exponential equations. These are the ones we're going to see a lot in the last few sections, or in the next two sections of, sorry, in the last section of chapter 4, and then in a few sections of chapter 5, okay? So let's solve these exponential equations. Let's start by relating the bases. And the reason why I want to do this is so that I can show you that some exponential equations you can just solve by, massaging them a little bit, by just kind of working with them a little bit, okay? Let's start with the first one. Let me pause really quick because I am about to open one of my other apps. Okay, sorry, I accidentally clicked on one of my apps at the bottom. One of my game clients. I didn't want it to pop up in the middle of the stream, or in the middle of the YouTube video. So 2 to what power is 32? Well, we know that's 5. But what is this whole thing about relating the bases? It means getting the same base. Okay, let's write that down. That'll help us for the last two. Get same base on both sides. Okay, so pretty much I want to rewrite one of the bases as the other, if I can, right? And as in this case, I can. I know 32 is 2 to the 5th power. And when I do that, well, then there's a property for an exponential equation. If you have a to the u power is equal to a to the v power, then automatically you know that u has to be equal to v, because the exponential function is called one-to-one, which makes this true. If it was not a one-to-one function, this would not be immediately true, but since it is one-to-one, it is, okay? So that's going to help us later, but for this one, it's pretty clear that it's 5, but then when we write this, we then see, oh, because we have 2's here, the same base, then we know the exponents have to be the same. I can now just set the exponents equal. So x equals 5, but we knew that, okay? Let's see it in another example where it's a little bit more helpful. So 3 to the x minus 1. Let's try rewriting this 1/9 to something to the power of 3. Well, I know 1/9. Let's start with the 9. We know 9 is 3 squared, right? 3 to the second power. So this is 1 over 3 to the second power. I don't want the 3 down here because I still can't relate it quite yet. I need 3 to a power equals just 3 to a power. This is 1 over 3 to a power, not the same thing, right? How do I get that 3 to the second power up in the numerator? I can make the exponent negative. 3 to the x minus 1 is equal to 3 to the negative 2. And I know from our properties from the first lesson we did in section D, we know that this is true by our properties, right? If I have a negative exponent, I can make it positive by throwing it to my denominator, and I can always go backwards, right? So now I have the same base. Now I can set the exponents equal to each other. X minus 1 is equal to negative 2. So now I solve for x. Add 1 to both sides. X is equal to negative 1. So that's the answer. Probably wouldn't have been able to see it immediately like over here, but now I see it, okay? So one more. 5 to the x power plus 7 equals 8. Just like with the logarithm, we want to get just like we had to get the logarithmic part by itself, here we want to get the exponential part by itself. So let's get rid of this plus 7. So minus 7 on each side, I get 5 to the x is equal to 1. Well, one way to write that is 5 to the 0 power, right? Because anything to the 0 is just 1. So here this is x equals 0. Okay, cool. So that's nice and not too bad. The only issue is that we won't always be able to deal with exponential equations in this manner. So in the next video, we'll go ahead and talk about what we do when we can't relate the bases. Okay, so meet me there in a few seconds, all right? See you there.